CloudDB, shaping your new normal.
Good morning, good afternoon, good evening to everyone, depending where you are around the world. Welcome to the 2021 APAC Groundbreakers Virtual Tour by APAC UC. This year event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you will be able to access to our replays until December 30. I would like to say thanks to all Oracle user groups and Java user groups, all 16 of them that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now, for today's session, A Collection, no matter how small, by Patrick Barrow. Please feel free to ask questions at any time by using the chat window on the right lower corner of your screen, and Patrick will be answering all your questions at the end of the session. If you have any issues during the presentation, please feel free to let me know by using the same chat window in the right lower corner of your screen. Without any more further ado, I want to leave you with this amazing session by Patrick Barrow. Patrick, is all yours.
Thank you, Francisco. I seem to be having a little bit of problems with the connection, so please bear with me. First of all, a little bit about me. I'm Patrick Barrow. I've been doing Oracle, working with Oracle since about 97. Back then it was Oracle 7. In 99, I started doing PL SQL, and that's what I've been doing ever since. I've been playing a bit with Apex, but not too much. In 2011, I became an Oracle Ace, and I was promoted to Oracle Ace Director in 2019. And that's mainly because I'm talking at a lot of conferences all over the world lately, just all over my office. I've built a couple of plugins for PL SQL Developer, my tool of choice. I also have written a couple of articles. Sometimes I blog, either on my own site or on the Quality site. I've written a couple of articles for All Things Oracle, but the site doesn't exist anymore. But they moved my articles to this link. I also had my own column in the OTech magazine, but that site doesn't exist anymore either. So I put them up on my own website. These are my contact details. I'll make sure the organization gets a PDF of the presentation of today. So there's the contact details will also be in there. Like I said, I'm an Oracle Ace. If you want to know more about this on the Ace program, go to the bit.ly link, Oracle Ace program. And if you want to nominate, well, it says here, nominate yourself. But I wouldn't do that. If you want to nominate someone you know, go to acenomination.oracle.com. I just clicked that and I didn't want that to happen. Let's if you want to try out all the things I'm presenting today, you can either use your own database, or if you don't have access to the newest, the latest and greatest, try to get an always free tier database. Oracle offers this free for life. Only thing is you have to log in about every week to keep your databases alive. If you go to the Quality blog, there's a 3-piece article I've written on how to make sure these stay alive using a Raspberry Pi and some Python code. So, topic of today. A collection is a collection no matter how small. Oracle was founded in 1977. So it took them about 15 years to get to Oracle 7. And before Oracle 7, Oracle just had SQL. The only way you could talk to the database was through SQL. In Oracle 7, they introduced PL SQL, the programming language, making it possible for you to interact with the database in a procedural language. And with the procedural language, they also introduced variables. Variables, either scalars, which are numbers, dates, or varchars, but and records, sets of different items like the records in your table, but also collections. Back then, they were called PL SQL tables, and PL SQL tables were collections of unbounded, well, only bounded by the memory you have available, collections of homogeneous variables, values. So either they're all varchars or all numbers, or they can be all records. You cannot mix and match numbers and varchars in the same collection unless you're using records. So you can have loads and loads of values in a single variable, a single collection. How do we build this? Well, back then they were called PL SQL tables, hence the names PT. We declare a type. Names PT is a table of, in this case, the varchar2 30, and then indexed by binary integer. That was the only way you could define a collection. Next, you create a variable based on this collection, and then you can start filling this up. You can fill it up at any number you want, anywhere between 2 to the 63rd to the minus 63rd, plus 1 to 2 to the plus 63rd minus 1. An amazing list of numbers. So I put something in position 1, then I put something in position 42, of course. If I then put something in position 10, it will slide in between the numbers 1 and 42. I can also use an operator on the collection, calling the count, asking it how many records are already in there. So I'm taking the count plus 1. I've got a count of 3 here, plus 1. So the next one will be put in at position 4. And the indices don't have to be all positive integers. They can also be negative integers. And then to display these, you'll have to make a while loop going from the first item and then using the index while the index is not null, print the name, the value, and then jump to the next item from where you are. So this going from -1 to 1 to 4 to 10 to 42. I even found an Oracle 7 installation. So I've created an Oracle 7 virtual box to display that this really works, and this really worked like this in Oracle 7. The code on the screen here is exactly what I just displayed, and this is the output. But filling these collections up all one by one takes up a lot of time, and most of our data is already in tables. So you'll probably want to fill up your collection by selecting it from a table. So I'm creating 2 tables, the relation types and the netmcdot table. Netmcdot is the mayor of Whoville, the village on which this presentation is based. Horton here's a who. I fill up the table relation types, and I also add a lot of characters to the other table, to the netmcdup table. And if I then create a cursor selecting the first name from the netmcdup table, where the type is 18, that means only the daughters, I think, relatives. Then I create the type again, same as before, names PL SQL table indexed by binary integer. And if I then open up the cursor and fetch a record, I put the record into the item in the names variable. And in this case, I can use a simple for loop going from first to last, because I know this is starting with 1 and then filling it up until whatever number of daughters there are in the table. So this is a lot easier to work with. Dense collections are a lot easier to work with. You can also use collections as parameters, so you can transfer all the values you want in one pass without the need for a lot of parameters, or even lots of calls to the same program. Oracle 8 was not so good. I think I never worked with it. Oracle 8i came up with new collections. PL SQL tables were now called index by tables, and they introduced the Varrays and the nested tables as two more collections, which could not only be used in PL SQL, but the nested table and the Varray can also be used in SQL. How do you create a nested table? Well, you create a type names nt nested table is a table of varchar 230, and in this case you don't have the index by. That's if you don't have the index by clause, then it's a nested table. And then you create a variable based on this nested table type. And these nested tables take a little bit more work. First of all, you have to initialize the collection. So before you can do anything with it, you have to initialize like a constructor. So we call the name of the type with the parentheses behind it. That's a constructor function. And then we extend and we make room for items. And in this case, I'm extending it by 5. You can extend it by almost any number as long as you have memory. But for this example, I'm using 5 to make room for 5 items. And then I can fill them up. And I can just fill them up by calling the collection variable and the index value. In this case, I'm filling it up 1 by 1, 2, 3, 4, 5, but I can fill it up in any order as long as I'm within the range of 1 to 5. And since this one is actually always a dense collection, you can again use the simple for loop, go from first to last to display the items in there. Another nice thing on Oracle 8i is that we can use a bulk collect. So we create a cursor, fetching the first name again, where type is 18. In this case, I'm fetching it into an index by table, index by binary integer again. If I then open up the cursor and I fetch bulk collect into my names variable, Oracle then just goes out to the SQL engine only once, fetches all the records directly in one pass back into my variable. And the variable will always be filled from index 1 to whatever number of items you have in your cursor. So we can use the for L index first to last, but we can also go from 1 to the number of items in there. It's always densely filled, starting at 1. Be aware, though, that if you're fetching a lot of data, all of this data will be put into memory. And so if you're selecting something like 100 megs of data, you will use up 100 megs of memory. And that's not a problem if you're the only one on the database. But databases are built to be used by multiple people at the same time. So the chances are, if you're using up all this memory and there's a lot of sessions doing exactly the same, you can blow up your server's memory. Luckily, Oracle has a solution for this. You can limit the number of rows you want to fetch each time in each pass. It takes a little more work, but your DBA will thank you for it. For the example, I'm using a limit of 4. So I've got the cursor again, selecting. That's all exactly the same. I'm fetching into the index by integer table again. I open up my cursor and then I have to do a loop. I have to start a simple loop, and I'm fetching the cursor bulk collect into my variable and then limit, and in this case I'm using the constant limit of 4. If I have something, if I've fetched something, then I can display the collection, and I want to exit this loop when the count fetched is less than the limit. Be aware, bulk collecting will never ever give you a no data found. It'll just return an empty collection. If you want to select multiple columns, you can do so by creating multiple multiple collection types. In this case, all indexed by binary integer. Then we have a cursor selecting the 4 columns, and we have 4 variables for the different collections. And if we then open up the cursor, and we can bulk collect into all these 4 variables. Bulk collecting is only possible into collections of scalars, and that isn't a problem. Sorry, missed one. That isn't a problem when you're selecting only a few columns, but if you have loads and loads of columns, it's going to be kind of a drag. It would mean defining a lot of collections of scalar variables. In Oracle 8i, we can also use the nested tables in the SQL layer of the database. So we create a type in the SQL layer of names as a table of the Varka 32, and then we create a package which returns that nested table type. And the body of these functions are fairly simple. The first one will just return 2 daughters of netmac. We create a nested table. We extend to make room for 2 items. We put in 2 items, and then we return the nested table to the calling program. We can also make a function which uses a cursor or select the first name bulk collect into my nested table, and then returns that. And using this function, these table functions, we can call them in the SQL layer by doing select column value. The name of the column is always column value. From the table, we have to cast the function as a names nested table. And we can do that for the relatives as well, where we say the type is 20. So we can select from a nested table, which is filled up by a PL SQL program as if it were a regular table. In Oracle 9i, we can also create a in Oracle 9i, the index by tables were renamed again, and now they're called Associative Array. And this Associative Arrays can also be indexed by varchar instead of just the numbers. So we create a names Associative Array as a table of varchar 230 indexed by varchar 210. And then we can fill up the collection using strings instead of numbers for indices. And these also remain the alphabetical ordering. So if you put in something Hedy before, it will come before Huli. Hilder will be put in between those two. So the order of the items in the collection is still maintained. In this case, it's alphabetical. Of course, if you want to display the contents, you will have to use a while loop, because there's no way you can use a simple for loop going from first to last, because this is by default a sparse collection. There. Remember, the bulk collect in Oracle 8i, for a cursor with multiple columns, we had to create multiple collections and multiple variables. Well, in this case, in 9i, we can create an associative array based on a row type. In this case, it's the row type of the netmcdot table. And then we can select all the fields from the table, and instead of creating a lot of variables for all the different collections, we just create one variable holding the collection of the records. And if you then fetch all the rows from the table, from the cursor, we can bulk collect it into the variable of the variable for the collection of records instead of all the separate variables. And again, this one is the bulk collect will give me a dense collection going from first to last. In Oracle 9i, we can also there's also an enhancement in the use of the table functions. We create a nested table in the SQL layer, and in this case we create the functions, but we call them pipelined. And what pipeline does is it makes sure as soon as a value is ready, it can be piped out of the function to the calling procedure or the calling statement. In this case, we will return the names nested table, but actually we pipe out every single row, so the rows of the Varka2. So we give row a value, and then we pipe that row out, and then we give row another value, and we pipe that row out. And if you're using a cursor, you can just create a cursor for loop for row in, and then the select statement. And in your loop, inside the loop, all you do is pipe the row out to the calling statement. And at the end, all you have to do is return control. A function has to end in return, but there's nothing you can return but control. Also 9i, we don't have to do a cast of the function to a nested table type again anymore. We can just do select star from table and then the function. So that's a lot easier as well. Using bulk processing can really improve the execution of your code. Let's create an enormous table, a big table, the fatmcdot. It's 10,000 times the data from the netmcdot table. And if I then create a really simple function, a simple anonymous block, doing a cursor for loop from this table and doing nothing really exciting, just making the ID value the same as whatever's in the record at that time. That takes about 4.5 seconds on my machine. If I then take the exact same table, but do some more work, make sure I'm having a cursor, I open the cursor and I fetch bulk collect in limits of 10,000 rows, exit when there's nothing to fetch. This is actually exactly the same contents of the procedure, except this time I'm using making use of the bulk collect features of Oracle, and then the execution time drops down to 1.2 seconds instead of 4.4. So it's pretty good. Going to 10G, if I do the first example again, so I'm dropping the table, creating a table of 10,000 times the netmcdot contents, and then doing the really simple procedure again. So just selecting everything from the table and using the ID for the variable. This takes 0.7 seconds, and of course Oracle 10 is probably better, probably faster. My virtual machine was maybe didn't have as much to do as the other one, but this is a significant difference. And in Oracle 9, if I changed all the code and made sure I was using the bulk collect, the bulk capabilities of Oracle, I can really take out a lot of processing time. If I do this on 10G, it goes down to 0.5, so 0.7 to 0.5. That's not too much. Oracle optimizes the cursor for loop into something which we're doing here, something bulk collecting with a limit of, I don't know, 100 or 1,000, something like that. So if you have cursor for loops in your code, you'll get the benefit of the optimizations Oracle does for you. If that still isn't enough, well, then you still have to do a little bit of work. But yeah, if the cursor for loop is fast enough, don't change it. So yeah, if it ain't broke, then don't try to fix it. If the speed is okay, make sure it stays like that. In Oracle 10G, we can create a nested table inside the package as well. So instead of creating a nested table in the SQL layer, I'm creating it inside the package and then doing the same stuff, creating a value, setting a value in a variable and then piping the row out. And here we do the same thing for the cursor for loop. And this also benefits from the bulk collect options optimizations Oracle does. So yeah, in Oracle AI we could create functions returning collections, and in 9i and 10G, it became a lot simpler, and we also had the pipeline thing, so we can speed up things even more, especially when you're using parallelism. Okay, Oracle 11, nothing really much happened. Oracle in Oracle 11 let me see this. Yeah, what I wanted to do is create a nested table type inside a package, and then select that nested table type in my PL SQL code. That is not possible. I still have to do a nested table type in the SQL layer before I can select from it in my PL SQL. In 12C though, we can create the nested table type inside the package specification, and then we can select from the nested table using the table operator inside a SQL statement inside in the PL SQL. So that's a lot simpler. We can also use an associative array. So that's with the index by PLS integer type inside a package specification. And that makes the code over here a lot simpler. And we can also use the table operator on this associative array, where it's actually not a SQL object. So that's a lot easier. We can now use the power of the simple collections, the associative array collection, plus the power of SQL. In Oracle 18C, we remember back when we started Oracle 7, we had to fill up the collection like this, L names and then index and then the values. In Oracle 18C, we can use the qualified expressions. We can use the constructor for the names type, for the and then set a value at position 1, Hooli, position 42, Hedy, etc. Be aware though that if you're using the lnames.count, in this case, when we're filling this up, count will be empty. So this one, holy, will overwrite holy. So this, in this specific case, the collection will only have 4 items. And then again, we can display the indices of the contents of the collection using a while loop. We can also use the qualified expressions to fill up records inside the collection. In this case, I'm creating a table of McDot records, and I can fill these up by going to the index number 1 and then put there the record, and the record is also with the qualified expressions. So it's a lot more for both. I think it's a lot more work, but yeah, it's almost like self-documenting code, and it'll be easier to find out what you've been doing, like a week from when you've been doing it. Okay, Oracle 19c. Well, nothing really much happened. Oracle focused on stability of the product since 19c is the long-term support release. So yeah, not really much happened. Then Oracle 20 didn't happen because of some pandemic. In Oracle 21, remember when we had the simple collection, we had to use the while loop to display all the items in there because it's a dense collection. We can now use a for loop for indices of, so this uses only the indices of the collection. So we can use a rather simple for loop to display to walk through the contents of the collection. And you might have seen this indices of if you're familiar with the for all statement. Using the for all, that's the counterpart of the bulk collect. Bulk collect gets the data from the database. For all sends the data back to the database, and you could use indices of there as well. 21c also gives us the values of. So instead of using the indices, it uses the values of the collection, and these will also be alphabetically. So it doesn't matter what the order of these things is; it will be sent out alphabetically. And another thing is you can use a for loop on the pairs. So the index value and the index and the value again all at the same time. You can select the index and the value at the same time. So instead of using index values here, you can just use these two variables. And that's about it. Like I said, this presentation was inspired by the movie Doctor Who and by Dr. Seuss. Horton Hears Who, animation by Blue Sky. That's where all the images came from. If you want to learn more about collections, I've written a couple of articles which you can find on these links: Collections Part 1 and 2 and Bulk Processing, which also goes into the not only bulk collect but also into the for all statement. If you want to learn more about easy initialization for records and arrays, go to the Oracle blog. Oh, as always, if you want to know more, go to Oracle Base. That's my go-to site as well. And all the scripts I've shown you are available at Live SQL. Search for collections, and you can find all the scripts I've shown you. Again, my contact details, go to my blog, sometimes a tweet. If you have any questions later on, send me an email, and that's it. Any questions at this moment?
Hi, Patrick. I don't see any questions up to this moment. If anyone has any questions, please feel free to enter by the chat window here or to the Facebook. If you're watching the replays, please also feel free to contact Patrick at any time to all the contact information he just showed, his Twitter handle, his email, his blog. You can contact him for many different ways. And let's wait a couple more seconds to see if anything comes through, Patrick.
Okay.
In the meantime, thanks again for taking the time for share all this with us. Excellent presentation as always, and taking the time to present to the APAC and global community, basically, because people from everywhere watch the replays and watch the recordings. And looks like there's no questions coming through in that case. Thank you again, Patrick, and have a good day, a good afternoon, good evening to everyone, depending where they are around the globe. And take care and be safe.
Thank you, and hope to see you again soon.
Likewise. Thanks. Bye-bye.
Bye.
CloudDB, shaping your new normal.